Hi, I'm Craig the Geologist, and sometimes our rock units don't line up the way we expect them to. What's to blame is called an unconformity. Let's talk about that a little bit. So when rocks are said to be lying on top of each other conformably, that means they are proceeding in a very predictable sequence. So we have a bunch of rock units, and we'll call these A, B, and C. And this rock unit is 60 to 65 million years old. And this unit is 55 to 60 million years old. And this one is 50 to 55. Well, these rock units are lying on top of each other conformably. But what about if we add another one? How about we put an asterisk rock unit up here, and this one is 5 to 7 million years old. What happened? Well, we've got an unconformity. Something has gone awry. And there are several types of unconformities, each one a bit unique. Let's go into it. All right, I'm leaving this up here for a moment because the first type of unconformity we're going to talk about is called a paraconformity. And you don't need to memorize these terms unless you're an actual geologist studying for a test. In which case, yes, memorize the terms, but just know that when you become a geologist later in life, we're going to refer to all these types of unconformities as unconformities. Maybe a sedimentary geologist will get a little pedantic about it, but if I'm talking about unconformity and someone says, well, actually it's more of a paraconformity, I'm going to be like, yeah, great. So there's a missing piece of rock there. Gotcha. Paraconformity is a flat unconformity, just like we have here. It's a missing section of rock. That missing section of rock might feel a little bit mysterious, but it refers to a period of non-deposition. Where might we have a paraconformity forming today? I'm not sure it's a great example, but the American Great Plains might be a case of a paraconformity, where you have neither a lot of erosion nor a lot of deposition going on. So I don't know the geology of the Great Plains off the top of my head. I can't quote you exact units and ages, but you might have something out there where the rock units are at ages, something like that, and then you just have a surface right here that you've just got a lot of prairie grass growing off of. And maybe it'll go like that for 5 or 6 million years, 10 million years, 100 million years. I don't know. The longer periods of time seem unlikely. But if nothing tectonically happens, then there might not be any deposition or erosion there. And then later on, when the Rockies get thrust up even higher and there's some sedimentary deposition, some energetic streams start to deposit flood deposits out there, you might end up with a layer out here that is, 2 million years into the future. We'll call it negative 2 million years old. So a paraconformity is a flat feature with a missing period of rocks, and it just refers to a period of non-deposition. Not necessarily a period of erosion, it's just a period where nothing was being laid down. This is similar to, but not the same as, an angular unconformity. And yes, I use these specialized terms so infrequently that I did indeed use the wrong term in this lesson. Anyways, getting back to it, an angular unconformity is an erosional feature. Let's have a look. Here's our angular unconformity. We see an erosional feature right here, where E, we'll say that's, just for convenience, 10 million years old. Angular unconformity. Erosional feature Maybe there was an eroded hillside here. Maybe there is a valley that filled in. Maybe something glacial happened. Could be a number of things. It would take a geologist to study it and explain it. But you've got an erosional feature, an angular unconformity, and a gap in time. It doesn't always have to be this dramatic. A disconformity could also, ignore that could also bit. We're moving on to disconformities now. Honestly, even to a geologist, this can feel a little pedantic, like we're describing different flavors of vanilla ice cream. Anyway, as I was saying, disconformities look like this. Instead of the top of this 50 to 55 million year old rock unit being flat, it might look like that. And then our E rock unit is on top of that, and it's 10 million years old. And again, you can see, all right, there might have been more rock units on top of it. Maybe the rock units were laid down, for another vertical 500 feet, and then there was a ton of erosion. Maybe a stream system came through and carried it all out. Maybe glaciers. Could be a number of things. But all of that eroded away, and then you've got this unit laid on top of it. That is a disconformity. Finally, we have a nonconformity. A nonconformity is a place where you have sedimentary rocks lying unconformably on top of igneous or metamorphic rocks. And so it might look something like this. All right, so in this case, the unconformity, the gap in the ages, is caused by the intrusion of this igneous body here. You can see it cutting through multiple layers. And we can use the law of cross-cutting relationships to kind of explain that. It isn't always so obvious, though. A more common situation is something that looks something like this. All right, so as a geologist, then you've got to figure out what's going on here. Well, if this is an igneous body and an intrusive, you might assume that was intruded in. But if you've got a metamorphic rock, say this is a gneiss here, well, gneisses aren't intruded into anything. And so this nonconformity is a missing time period here. I mean, this rock unit, this gneiss, might be 3 billion years old, and this unit here might be, 100 million years old. That's a pretty big gap. What happened in between there? Well, you can guess that it was probably erosion, or maybe it was non-deposition for 3 billion years, but that seems wildly unlikely. There's explanations, but it's called a nonconformity when you have an igneous or metamorphic body and a big missing gap of time usually, and a sedimentary rock on top of it. So these are your types of unconformities. Memorizing the names, really not important unless you're gearing up for a test in your first or second year geology class. However, it is important to know that these gaps in time are understood, and we can use what we know about unconformities, whether they're angular, para, nonconformity, to understand why there's missing periods in time. And sometimes those gaps actually do tell us a little bit about the story. A big gap in time can tell us that there was a big erosional event. Maybe it was a mountain range for a while, and we can take a look at the missing period of time. And while we can't learn as much about it as we could if we had preserved rock units that, detailed exactly what was happening, we can know that, okay, it was eroded from, 50 million to 100 million years ago, sometime in that period. So maybe this period of time involved a period of uplift, and the region was lifted up and eroded away. We can learn about the rocks this way. It's amazing that geology has progressed to a point where we can learn about the history of the planet from the lack of rocks in some cases. Sometimes the lack of rocks is maddening. In Michigan, we have an enormous unconformity. We have rock units coming up to around 200 million years old, and then nothing until the modern day, because the glaciers came through and bulldozed everything away. So sometimes people ask, hey, did dinosaurs roam Michigan? We don't know. there's no record from the age of the dinosaurs in Michigan. All we can really say for sure is that either all those rocks were bulldozed away by the glaciers, or that it was a highland area where there was no deposition going on. We just don't know. I hope that explained a little bit about geology. Join me next time.